Welcome to Shanti-Peace for Mathematics. In this video, we are going to discuss regarding a relation between roots of polynomials and its coefficient. So let's talk about the roots of polynomials and its coefficient. For example, if we talk of a quadratic polynomial of the form ax square plus bx plus c equal to 0. And suppose that alpha and beta are the two roots of this polynomial. As alpha and beta are the two roots of this polynomial, we may write down the equation of, or I can write down this as same as x minus alpha, x minus beta equal to 0, and that can be expressed as x square minus alpha plus beta x plus alpha into beta equal to 0 by multiplying these two brackets. And the equation 1 and equation 2 are the same equation, and if this a is non-zero, then this equation 1 can be written as this form, that is x square plus b by a x plus c by a equal to 0. So hence this will gives you very interesting relation between the roots of polynomial, that is alpha and beta, and its coefficient, they are a, b and c. They are the coefficient of this polynomial, and alpha and beta are the roots. So we'll have a relation that is alpha plus beta, that is the sum of the roots is nothing but the minus b by a, and alpha into beta, that is a product of roots, will be c by a. So in this manner, if you have a second degree polynomial, then we have a such relation, and in this manner, if you have a more than second degree polynomial, that means any polynomial of degree n is given, and the same kind of relation one can derive. For that, we should have some polynomial. Let's say the polynomial is a0 x power n plus a1 x power n minus 1, a2 x power n minus 2 up to so on, an minus 1 x plus an is equal to 0. Suppose this is the polynomial of degree n. So obviously this a0 will be non-zero. And suppose that alpha, beta, gamma, or alpha 1, alpha 2 up to alpha n are the roots of equation 1. What is the equation 1? I can say this is the equation 1. Then there is a relation between this alpha 1, alpha 2 up to alpha n and this a0, a1 up to an are alpha 1 plus alpha 2 up to alpha n will be minus a1 upon a0. Alpha 1, alpha 2, alpha 2, alpha 3, all the possible pair, that is alpha 1, alpha 2, alpha 2, alpha 3, then alpha 1, alpha 3, and so on. All the possible pairs you will have at the last, might be it is alpha n minus 1 alpha n, will be a2 by a0. That means all the possible pairs of this two pair. Alpha, the third relation we get alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 4, and so it is the all possible pair of three roots. That is, we can, in the last term might be you will have this term, that is alpha n minus 2, alpha n minus 1, alpha n equal to minus a3 by a0. And in the same manner, the last term will be alpha 1, alpha 2, alpha 3 up to alpha n. So that is a product of all the roots will be minus 1 raised to n, an upon a0. And one can prove this is by mathematical induction very easily. So we are not going to discuss the proof of this, but this is the relation between a coefficient of polynomial and its roots. By the notation, this can be written as summation of alpha 1. So the summation of alpha 1 means it is a sum of all the roots. Here we write this is as notation, that is summation of alpha 1 alpha 2. That means all pair of two roots, that is alpha 1 alpha 2 alpha 1 alpha 3 and so on, whatever the possible pair is there, we can write down this all the terms as a summation of alpha 1 alpha 2. This we can write as summation of alpha 1 alpha 2 alpha 3 because it is a sum of three, product of three roots, and all the possible pairs of three roots will be there. That is the summation of that. So in that manner we can having the notation of this roots of the polynomial and the coefficient of a polynomial. So we have to solve certain examples based on this concept in this video lecture. The first example, solve the equation x cube minus 7x square plus 36 equal to 0, given that one root is double of the other. That means we have to solve this polynomial. That means I need to find out what are the roots of this polynomial, and the given condition is one of the root is double than the other. So let the roots be alpha, beta and gamma, such that what is given is one of the root is double than the other. So that say beta is equal to 2 times alpha. This is given. And as per we have seen the relation between the roots of the polynomial and the coefficient of the polynomial, we know that alpha plus beta plus gamma equal to, as per the previous things which we have discussed, if we compare this equation with a0 x cube plus a1 x square plus a2 x plus a3 equal to 0, then if you can see that here alpha 1 plus alpha 2 plus alpha n is minus a1 upon a0. So here it is a polynomial of degree 3. So alpha 1 plus alpha 2 plus alpha 3. So here is, I have assumed as alpha beta gamma is minus a1 upon a0. And if you compare this with this equation, a0 is 1, a1 is minus 7, a2 is 0 and a3 will be 36. That we can see from this. So here it is minus 7, so it is minus plus 7 upon 1. Alpha beta plus beta gamma plus alpha gamma. These are the pair of three terms we'll have, and that is equal to a2 upon a0 as per the previous thing. That is all possible pair of product of two pairs, that is this and that is a2 upon a0. So that is a2 upon a0, a2 is 0, so that's why this is 0. And the last one is a product of 3, but it has only 3 roots, so that's why it is a product of all roots, will be a3 minus a3 upon a0, because in the previously it is minus 1 raised to n is 3 here, degree is 3, and it is an alternating sign. So you can just see that first it is minus sign, then plus sign, then minus sign. Now it is minus a3 upon 0, that is 36, minus 36 upon 1, so it will be minus 36. Now if we can see that this is the given condition, this is the equation 1, if I can say, this is equation 2, I can say, this is 3 and 4. So we have a 4 equation and 3 unknowns. If we can able to solve this 4 equation using these 3 unknowns, we have the roots of this equation. So let us substitute this value of beta into the equation 2 and equation 3 and equation 4. Let's see what we have. So equation 2 becomes, that is by putting 2 alpha here, that will gives you 3 alpha plus gamma equal to 7. Then if I put beta is equal to 2 alpha, this is 2 alpha square plus this 2 quantity will be the same because it is 2 alpha here if I substitute. So let us write that is 2 alpha square plus 2 alpha gamma plus alpha gamma equal to 0. So this will gives you 2 alpha square plus 3 alpha gamma equal to 0. And the last one will have alpha beta gamma. Beta is 2 alpha, so it is 2 alpha square gamma equal to 36, minus 36. Now if I solve this 2 equation, so this will gives you again alpha If I take common out, alpha is common out from this, then it will be 2 alpha plus 3 gamma equal to 0. And if I can solve the equation 1, or I can say this is equation number 5 and this is 6. So this will gives you alpha equal to 0, or 2 alpha plus 3 beta equals 3 gamma equal to 0. But alpha equal to 0 is not possible because it's not satisfying our required equation. The alpha equal to 0, it is not satisfying this equation. Alpha is the root of this equation. So alpha equal to 0 is not possible value. So the possible values is this. So that we have now two equation, 2 alpha plus 3 gamma equal to 0. Another our equation is 3 alpha plus gamma equal to 7. So I can multiply this equation by 3 and this equation by 2, and then we add them. So if we have subtract this equations, then this will become 6. So this will be cancelled out. This is 3 3 is a 9 gamma minus 2 gamma. So 9 gamma minus 2 gamma equal to minus 14. So this will gives you 7 gamma equal to minus 14. So that will gives you gamma equal to minus 2. So if you have a gamma equal to minus 2, if you substitute in equation 5, then 3 alpha minus gamma equal to 7 we have. That will gives you 3 alpha equal to 9, and that is gives you alpha equal to 3. So alpha is 3, gamma is minus 2. So the last equation, or beta is equal to 2 alpha is there, but beta alpha, the value of alpha is 3, so that is beta is 6. So therefore the roots of equations are, given equations are 3, 6 and minus 2. We are the roots of the given equation we have. Let's have the another example. Suppose this is the given equation, x raised to 4 minus 2x cubed plus 4 x square plus 6x minus 21 equal to 0. The question is to solve this equation, and given that the sum of two of its roots is 0. This is a 4th degree polynomial. So by fundamental theorem of algebra, it has a 4 roots. So suppose that alpha, beta, gamma and delta are the roots of given equation. Let's say the equation is 1. So by relation between the coefficient of polynomial and the roots of polynomial, if I compare this equation with a0 x raised to 4 plus a1 x cube plus a2 x square plus a3 x plus a4 equal to 0, we will have alpha plus beta plus gamma plus delta equal to minus a1 upon a0. But if you can see that a1 will be minus 2 and a0 is 1, so it is 2. The second is alpha beta plus all the possible pair of two roots, so that we can say it is summation of alpha beta, that is a2 upon a0. That will gives you a2 upon a0. a2 is 4 and that is 1, so it is 4. Then it is summation of alpha beta gamma, that is a pair of all the three roots, that is a3 upon minus a3 upon a0. a0 is 1, a3 is, you can say, 6, so it is minus 6. And alpha beta gamma and delta, that is the 4 roots, that is a4 upon a0, but a4 is minus 21 upon 1, so it is minus 21 is there. So these are the relation we can have. Now we have to solve this, and one of this another condition is that sum of two roots of this is 0. So that is the next condition we have, that is alpha plus beta. Suppose that as per the given situation, the sum of two roots, that is alpha plus beta, is 0. Let's assume. So that will gives you alpha is equal to minus beta. Now from this equation 2 we can have certain results, that is this is alpha plus beta plus gamma is delta is equal to 2, and alpha plus beta is 0. So that will gives you, from 2 we can have, that is gamma plus delta is equal to 2. So now one of the ways to solve this equation is to solve this 4 equation 1, 2, 3, 4, 5 and these 2 equations, and you can have your roots of the alpha, beta, gamma and delta. That is one of the ways to solve this. Here I am strictly use some different techniques. The quadratic equation having roots alpha and beta can be written as x minus alpha into x minus beta equal to 0. So this will be x square minus alpha plus beta x plus alpha beta is equal to 0. And similarly, if some polynomial, quadratic polynomial is there, for that if gamma and delta is the roots, then we can write down x square minus gamma plus delta x plus gamma into delta equals. And the product of these 2 quadratic factors will gives you our equation, that is x power 4, because ultimately the equation is the product of these 4 terms, that is x minus alpha, x minus beta, x minus gamma, x minus delta. We can have that x power 4 minus 2x cubed plus 4x square plus 16x minus 21 is equal to x square minus alpha plus beta x plus alpha beta, x square minus gamma plus delta x plus gamma delta equal to 0. That we can have. But this is the equation where alpha beta is already given to us, that is 0. So this is 0x, so it is plus alpha beta, and this will be x square minus 2, because alpha plus delta is 2, that we have concluded, so that is 2x plus alpha delta is equal to 0. Now if we compare the coefficient here, both sides, because if I multiply this 2 brackets will gives you x power 4 minus 2x cube plus 2 alpha x square plus 2 alpha beta x square minus 2 alpha beta x plus last term is alpha beta gamma delta. So comparing coefficient both sides, we get this coefficient of x power 4 is 1, x cube is minus 2. Now gamma delta is 4 plus gamma delta plus alpha beta is equal to 4, because this plus this term is there, and this will gives you minus 2 alpha beta is equal to 6, and alpha beta gamma delta is equal to minus 21. So this will gives you alpha beta is equal to minus 3. Since alpha beta is equal to minus 3, if I substitute here in this, then you will have x square minus 3 equal to 0, because this is equal to 0 means either this equal to 0 or this equal to 0. So this will gives you x square equal to 3, that will gives you x is equal to plus or minus 3, root 3. So these are the 2 roots we have. Now we need to calculate another 2 roots. We need to have the value of gamma into delta. And since alpha beta we have, from this we can have the value of gamma into delta. So the gamma into delta is minus 21 upon minus 3. So that is gives you 7. So gamma delta is 7. So another equation we can have, that is x square minus 2x plus 7 equal to 0. And this is a quadratic equation, so it is easily calculated by ax square plus bx plus c. So this will gives you plus 2 plus or minus b square, that is 4 minus 7 into 4 upon 2a, a is 1. So this will gives you 2 plus or minus 7 4s are 28 minus 4 minus 24 upon 2. So this is gives you, if I can take common 4 from this square root and cancelling out 2, so this will gives you 1 plus or minus root 6i. So hence the roots of the polynomials are root 3 minus root 3, 1 plus root 6i and 1 minus root 6i. They are the roots of this polynomial that we can get. Let's take another example. Suppose given that x power 4 minus 2x cube minus 221x square plus 22x plus 40 equal to 0, whose roots are in AP. AP means it is arithmetic progression. So given that the roots of this polynomial are in arithmetic progression, we have to solve this polynomial. So we know that first of all the definition of arithmetic progression is a plus h, a plus 2h. So it is a difference of two terms is a constant. And here it is this polynomial is of 4 degrees, so it has 4 roots. So either you can take this a plus h, a plus 2h and a plus 3h as a roots. That is one of the ways to assume the roots of this polynomial, because it is given that they are in AP. And another way to make a simplification, you can make a center and you can assume that the roots, be a minus 3d, a minus d, a plus d and a plus 3d. Why we have taken this? Because when you do the sum of the roots, then your d term will cancel out. You will directly get the value of a. The relation between roots of the polynomial and the coefficient of this will get a minus 3d plus a minus d plus a plus b minus plus a plus 3d will gives you minus 2 upon 1. So that is minus plus 2 upon 1. So this will get cancelled out with this. This is get cancelled. D is cancelled. So we'll have it as a 4a equal to 2. So that will gives you directly the value of a, that is 1 by 2. And the last, we know that the product of roots will be minus 1 raised to n a_n upon a0. But here n is 4 and a_n, that is a4, is 40. So 40 upon 1 is there. So it is 40. And the product of roots, that means we do the product of this one, that is a minus 3d, a minus d, a plus d, a plus 3d is equal to 40. So this will gives you a square minus d square, and a square minus 9d square is 40. And the value of a is 1 by 2. So if I substitute that value here, then this is 1 by 4 minus d square into 1 by 4 minus 9d square equal to 40. Let us take the LCM and simplify this, or I can do multiply this to brackets. So this is 1 minus 4d square, 1 minus 36d square. It is 40 into 16 is there. If you multiply this to bracket, this is 1 minus 4d square minus 36d square plus 144d square equal to 640. So therefore it is 144d square minus 40d square minus 639 equal to 0. Now this is a d power 4 is there, and this is the polynomial. You can say it is in power in d square, or quadratic polynomial in d square. So that means d square we can have by finding the roots of this, that is minus 40, that is plus d square, that is 1600 minus 4 into 144 into minus plus 639 upon 2 into 144. And if you simplify this, then we will have two roots, that is 9 by 4 or minus 7 by 36. Minus 7 by 36 is not possible. This value is not possible because it is a d square. So only possible value is 9 by 4. So therefore the roots, that is we have d, which is plus or minus 3 by 2, and therefore the roots are a minus 3d, a minus d, a plus d, and a plus 3d will gives you, that is 1 by 2, because the value of a is 1 by 2, and the value of d, if I take 3, that is 9 by 2. 1 by 2 minus 3 by 2, 1 by 2 plus 3 by 2, 1 by 2 plus 9 by 2. So therefore this will gives you minus 4. This will gives you minus 1, 2 and 5. They are the roots of the given polynomial. Let us solve one more example. Let's have the x power 4 minus 15x cube plus 35x square minus 30x plus x is equal to 0. Given that the roots are in GP. The roots are in GP means they are in geometric progression. So as we have did in the arithmetic progression, the same technique we can use for the geometric progression, and we know that the geometric progression is of the form AR square, means the ratio is the same. These are the 4 roots we have. But to make a simplicity, we assume the roots are A upon R cube, A upon R, AR and AR cube. They are the roots of this polynomial. And so when we do the product of roots will be minus 1 raised to n an upon a0. But an is here 8 and n is 4, so that's why it is a plus sign. So 8 upon 2 is there because a0 is 2. Product of this one will gives you this r cube is cancelled out and r is cancelled out, so we'll have a power 4 will be 4. That will gives you a square will be 2. Now I will make a pair of these 2 roots and these 2 roots and make this equation is x minus a by r cube and x minus a by r, a into r cube. Another one is x minus ar, a by r and x minus ar. This will be the same as our original equation, that is 2x power 4 minus 15 x cube plus 35 x square minus 30x plus 8 equal to 0. And we do product of this two, then we will have x square minus a by r cube plus a r cube x plus the product of this two, that is a square. And when you do the product of this two will gives you x square minus a by r plus ar x plus a square, that is equal to this equation is there. Now the value of a square we already have, which we have calculated in the previous slide, that is 2. So therefore this is x square, and if I call this value is p, then it is px plus 2 and x square minus qx, if I call this is the qx, then plus 2 equal to this equation, that is 2x power 4 minus 15 x cube plus 35 x square minus 30 x plus 8. Now to adjust this 2 here, I multiply 2 here on this side also, make this 2 visible or to adjust that. And then we compare the coefficient both sides. So comparing coefficient of x cube and x square. Let's see what will happen. So here the coefficient of x cube is minus 15. What will be the coefficient of x cube on this side? When you multiply this px term to x square, then it will have a coefficient of x square. So it is minus p. And when this minus qx is multiplied to this x square, then it is minus q. So this will gives you p plus q is 15 into 2. Yeah, obviously into 2 is there. 2 is forgot. So it is 15 by 2. And coefficient of x square here on this side is 35. So x square, when you this multiply this x square with this 2, then it is 2. And when this x square is multiplied to this 2, then it is plus 2. And then whole term will multiply 2. So it is 2 plus 2 into 2. Plus when this x and this qx, this p of x and this px and this qx is multiplied together, and that minus minus become plus. So that's why it is plus sign. 2 times pq is there. Therefore this is pq, 2 times pq plus 8 is equal to 35. So we have now, that is p plus q is 15 by 2 and 2 times pq plus 8 is equal to 35. So PQ value is 35 minus 8 by 2. So 35 minus 8 gives you 37 by 2. Now the roots, from this we can have the value of P and Q. This will gives you the value of P and Q because x square minus P plus Q, x plus PQ equal to 0 will be same as x minus P, x minus Q equal to 0. We have this value sum of the roots of this thing, that is x square minus 15 by 2x plus 27 by 2 equal to 0. Now when you solve this equation, we will have the value of P which are 9 by 2 and Q will be minus 3. Since we have the value of P and Q, if I substitute that value of P and Q here, then we will have the roots of our polynomial, because there are the unknown things we can have. Therefore, this is 2 into x square minus P, that is 9 by 2 x plus 2, x square minus 3x plus 2 equal to 0. This equation is equal to 0, that means x square minus 9 by 2 x plus 2 equal to 0, or x square minus 3x plus 2 equal to 0. And if you solve this, again this quadratic equation by the formula b square minus 4ac upon 2a, this will gives you two roots. These are the 1 by 2 and 4, and this will gives you two roots, that is 1 and 2. So altogether the roots of the given equations are this 4. And similarly you can solve so many examples which I am giving you as an exercise. You can try for those examples. Thank you very much for listening me. See you in next video. Till then, bye bye, sayonara.